To find the inverse of a function informally, we are just taking y equal to our function, and then we switch x and y. So this gives us x equals 2y plus 1 over 3. Okay, notice the x and y just switched positions. And then we solve for y. So if we multiply both sides by 3, we get 3x equals 2y plus 1. Subtract 1 from both sides, you get 3x minus 1 equals 2y. And then divide both sides by 2, and we get 3x minus 1 over 2 equals y. And once you've got y by itself, that function is your inverse function. So f inverse of x equals 3x minus 1 over 2. Okay, then we want to verify these two identities here. When you plug a function into its inverse, you should end up with x. Okay, so starting with f of f inverse of x, okay, is this thing that we just found. So we're going to go ahead and plug that in there. We get our 3x minus 1 over 2. Okay. Well, now we're going to plug that as our input for f. Okay, now f is 2 times the input, which in this case is the entire 3x minus 1 over 2, and then plus 1 all over 3. Okay, so I've just applied f to this input, and there's my f. And now we need to simplify. Well, 2 times this thing, the 2's will cancel, and we're left with 3x minus 1 plus 1 over 3. Now the minus 1 and the plus 1 cancel. We have 3x over 3. And of course, those 3's cancel and we get x. So we've verified that one. We're good there. For the next one, f inverse of f of x, okay, that's this thing here. And so we're going to plug that in here. So 2x plus 1 over 3. And, well, that's equal to, now we're plugging this into our inverse. So that's 3 times the 2x plus 1 over 3 minus 1 over 2. Now we simplify. We've got a 3 and a 3 divided by there, so we're cancel those two things out. We get 2x plus 1 minus 1 over 2. The plus 1 and the minus 1 cancel, and we get 2x over 2. And of course, the 2's cancel there, and we get just x. So we verified both of those compositions, both of these identities. Okay, for the domain and range of f and f inverse. So the domain of f is the same as the range of f inverse. Okay, so once you find one of these, you know the other. Well, looking at our function here, we're not dividing by x, and we don't have any square roots. So we don't have any restrictions here. So our domain of f is all real numbers. That makes the range of f inverse also all real numbers. Okay, then for our domain of f inverse, that's the same as the range of f. And we do the same thing where we say, well, look at the domain of f inverse. F inverse is this 3x minus 1 over 2. Again, there's no restrictions on this. Okay, there's no dividing by x, no even roots. So that is all real numbers also. And of course, the domain of f inverse is the same as the range of f. So that is also all real numbers. Okay, and now graphing both f and f inverse on the same set of axes. Let's go ahead and do that here on in our calculator. And go ahead and add a graph. And we want to graph both of these. So, let's look at our functions. We had 2x plus 1, 2x plus 1 over 3. So we'll graph that. To add another graph, we click tab, and we'll put in our inverse, which is the 3x minus 1 over 2. So 3x minus 1 over 2, and graph that. Okay, we see both the graphs, and the relationship we need here is we need these to be the reflection of each other over the line y equals x. Let's go ahead and graph y equals x, just so we can see that reflection. Okay, we see that the red and the blue are the reflections of each other across the line y equals x. So we've got those graphs, and that's kind of the relationship we're looking for. Describe the relationship between the graphs of f and f inverse. So we say, well, the graph of f is the reflection of the graph of f inverse over the line y equals x. And that's kind of the relationship that's important to know.